Conditional probability. What is conditional probability means? We have seen things about conditional events. When we will say conditional events, happening of one event given that it happens after one another event. Okay. Likewise, when I mention P of A given B, see, this should not be read as A by B. We should not read this like A by B. How we should read this? P of A given B. Okay. Meaning what? Happening of A after B. What comes in the denominator that happened before, past. Okay. So, formula for that is P of A intersection B divided by P of B. What if P of B given B? Meaning what? Which one happens? After A. Okay. A happens first, after that B will happen. For that, the formula is P of A intersection B divided by P of B. Okay. Actually, for this, the actual formula is P of B intersection A. But I wrote A intersection B just to give you an idea. The simple similarities you can see between these two events. Okay. What comes in the denominator? That's probability will come in the denominator. That's how. So here. So B given A means you won't get confused. Usual idea is this event intersection this event. Probability of this event intersection that event divided by probability of this denominator given event. That is how the probability works. Now, the multiplication theorem. Previously, we have seen addition theorem on probability. That states what? The addition theorem on probability, P of A union B equals P of A plus P of B minus P of A intersection B is given by the addition theorem of probability. Now here the multiplication theorem means this will give you the value of P of A intersection B that can be equated from either this equation or this equation. Okay, sorry, this condition or this condition. So A intersection B is value here what? P of B into P of A given B. What comes down, that has to be multiplied. Or P of A if you are taking means this is P of B given B. Clear? This has two formula. This is called multiplication theorem on probability. What happens for three events? We will take A, B, C three events. There are two kind of independency will occur in three events. One is pairwise independent. By certain pair only the independence will occur. Either A and B are independent. That means P of A into P of B, or else B and C are independent, or else C and A are independent. This is called pairwise independent. Along with this, if you include one more condition, all these three occurs, but A, B, C are not independent altogether. If all these three occurs, when it will become independent means one more condition will be added. That is P of A intersection B intersection C is P of A into P of B into P of C. then only we can say all the three events are independent. If this condition doesn't occur, only this occurs, means we can say it is pairwise independent. Clear? Given three events, man, in the three events, if all these three pair only occurs, this one not occurs, only this pair occurs, means we can say those three events are pairwise independent. Okay, we can't say A, B, C are independent events. Instead, we should say A, B, C are pairwise independent events. Along with these three, if this condition also appears, means we can say A, B, C are three independent events. Okay, any doubts in this? Okay. Also, if A and B are independent, two events A and B are independent, then we can say A complement and B are independent, and vice versa, B complement and A are independent, or else A complement and B complement are independent. So two events are independent means their conjugate and the other, or else both conjugates, they are independent events. Clear? Okay, then we will move to the questions.